This video is to walk you through how to do question 51 and 54 on your homework with your calculator. We're going to try to be very calculator efficient and do it as quickly as possible. So on 51, you have the function f of t equals t squared sine of t. And here the variable really doesn't matter, so I'm just going to open up a window and we're going to watch it flash at us. Let's see if it'll stop. Oh, good. There we go. X squared. And then we're going to say times sine of x. Hopefully. Come on. There we go. All right, and then I'm going to hit enter, and we've got this crazy graph going on. Now, I'm going to look at this and see that the graph says that we really only care about what's going on from 0 to 2 pi. So again, menu, and I'd like for you to get used to doing some of your own windows just so they match the window from the problem. So we've got from 0 to 2 pi, so I'm going to type in 0 to 2 pi. Could do 6.28 and it probably would have taken less time, but there we go for being exact. Okay, and the min and max really don't matter, but I do remember from this problem that it does go a little bit lower than that, so I'm going to put in negative 20 and let's see if that'll give it to me, and then hit OK. And we'll wait and hope for the best here. And there it is. And see, my negative 20 wasn't even quite enough. All right, so here's the graph of f of x. No big deal. Y'all could have done that without me. And you're supposed to sketch that onto your paper, so you can do that. And the next thing it wants us to do is to sketch f prime. So you could find the derivative and then plug it in, but this was the reason I wanted to show you the video. So let's tab and put in a second function. And with this, we're going to go over here to our little textbook, go to derivative, and see how it sets this up. So it's going to take the derivative of what you tell it to. And we could type the function in again, but why do it when we've already done it once? So I'm just going to put f1 of x, which is what it is, where our function is, comma x, because it needs to know what it's taking the derivative with respect to. Bam, and there's our derivative graph. So that takes care of A. You're supposed to sketch the graphs of f and f prime on the same set of axes. I don't even care what the derivative is that we found in A. Now, to find the critical numbers of f in the open interval. So remember that our function is the blue, and it increases and then it decreases. We can't really see the y value, but we can kind of see that it's going to happen somewhere in here. And then it increases again. That's pretty obvious. And we could find those values by taking the derivative, setting it equal to 0, and solve for x. But I want to show you something else. Let's look at the graph of our derivative. Do you see that the 0 of our derivative matches the x value of our max? And over here, even though we can't see it, the 0 of our derivative matches our min. And so what I'm going to do is find a 0 versus a max or min. This is me using the calculator to take the derivative and set it equal to 0. If we're going to use the calculator, let's use it for all it's got. So menu and analyze graph. You've done this before with tracing and things, and we're just going to go to 0, and we want the 0 of the derivative. So there's my lower and my upper, and we've got a 0 at 2.29. And I know I would rather you use 3 decimal places, but for this I think I'm fine with us just using 2. And then we should have another 0 over here, which is going to represent where our minimum occurs on the graph of our function. So let's do this again and analyze graph. We'll go to 0. And again, I want it of this graph, so I'm to the left, 0 over to the right, and there's 5.09. Just to give you some confidence in that this actually works, that the 0 of our derivative is where the min or max occurs of our function, let's actually find this maximum value right here. So menu, analyze graph. This time I'm going to do the maximum of the graph, and I don't know why it did that. And so lower, upper, and you can see that both of those line up with the same x value. Pretty cool. So that's really all I'm going to do with the calculator. What I've done on the homework, and I can come back and show you, is that I've graphed both the function and its derivative. Let me get it in the window here. And then I did a sign analysis based on the graph. So here is my derivative right here. And my derivative is positive. See, that's the graph of my derivative, and my derivative graph is above the x-axis, so it's positive. Here's where it's 0. Then it's negative from 2.29 to 5.09. And what does it mean when your derivative is negative? It means your graph, or your function, let's get some color going here, is actually decreasing. So the values of where f prime is negative is where f is decreasing, and then to finish it up, where f prime is positive, f is increasing. And so I just took the number line, and that's where I wrote in my analysis, that because the derivative was positive, negative, positive. And again, I'm looking at the graph of this derivative, which is right here, and saying it's positive. Oop, I used a pronoun. The derivative is positive. The derivative is negative. The derivative is positive. And then what that means for the function itself, where the derivative is positive, the function is increasing. Where the derivative is negative, the function is decreasing. And where the derivative is positive, the function itself is increasing. You can see that I did the same thing on 54. It was a little bit messier. There's one more critical value in the mix, so there's a little bit more to do, but I hope this helps.